Okay, so technically, I've already done a video explaining the odd questions on this, and right now I'm actually recording on to explain some of the even questions with you guys. So we're going to be graphing absolute value functions, and absolute value functions are technically piecewise functions, but yesterday we learned the actual notation of the vertex form. So let's write that down up here. Y equals A open absolute value, x minus h, close absolute value, plus k. That's what we learned in our notes yesterday. That's what we need to have memorized by today, okay? If you understand this form, you'll know that the a value is the number in front of the absolute value, and that number, you're going to think of it as rise over run, kind of like the m value and y equals mx plus b. This is technically the slope, okay? And then the h and k, these two numbers actually provide you with the vertex, okay? So you know what? Let me jot this down on the side right here. I don't have enough space. So here it is. And we call it vertex form because you could identify the vertex by thinking opposite on h and taking k for what it is. So step one to graphing is to identify your vertex. The vertex is a coordinate. It's the most important point. Okay, and it's going to be HK, H and K. You know what? Yeah, we'll put H and K. And when you identify H from your equation, when you're graphing it, when you identify H, you want to think opposite of what you see here because there's a minus sign in the original vertex form. So if you happen to see a -3, this is going to be a +3. If you happen to see a +7, this is going to be a -7. When you pull it out from there to be your x value of your vertex, you got to think opposite of what you actually see because of this minus sign. And the k, you take it for what it is. So step one on graphing, that's what we're going to be doing on this paper, on this handout, is to identify your vertex, think opposite on h, take k for what it is, and then from the vertex, rise and run according to your a value. Okay? Pretty simple. So let's do a couple of these even questions. So we're on number 2. And again, the first thing to do is to find your vertex. I'm going to put a little v and a little coordinate right here. And I always identify the vertex by thinking opposite on h. And h is always being subtracted from x inside of the absolute value. So you think opposite of +3, which is a -3. And then you take k. The k value is the number that's being added or subtracted outside of the absolute value. And as you can see, there is nothing that's being added or subtracted right here, which means that k is 0. So we're going to put a 0 for the k value, okay? That's your hk value. So let's plot that point, -3, 0, -3 on the x, 0 on the y. It's right there. And from that point, I need to rise and run according to my a value. And my a value is the fraction that's out in front. Now, there is no number, so technically the number is 1. And if I make it look like a fraction, it's up 1 over 1. So from this point, I want to go up 1 over 1 and put a dot right there. When we did lines, y equals mx plus b, we would go up 1 over 1, then we would use the pattern backwards to extend it in the other direction, but we're not going to do that here, okay? You see, based on yesterday's lesson, we should know that when we do absolute values, when we have these little sticks right here, it ends up giving us a V, right? It's like 2 little sticks coming out of that vertex. So not only do we rise 1, run 1, but we also rise 1 and run 1 in the other direction to create that V. And you could continue to rise 1, run 1 in both directions as far as you want. And there's your graph. So in the future, maybe on the quizzes assignment that we're working on today, I may give you this graph right here, and I'll tell you plot, let's say 6 of the points. I may say plot 6 points. So obviously you always start with the vertex. You would put that dot right there. And then you do this one, that one. That's a total of 3 so far, 4, 5, 6. So it's not always going to be perfectly 3 on this side, 3 on that side. It depends where your vertex is at, okay? So pay attention to that. Anyway, what is our domain? Well, the domain are your x values. And this, does it go to the left forever? Does it go to the right forever? Yes. So technically, x equals all real numbers. And I might as well say this now. This is true for every single absolute value function. It doesn't matter if you have a really wide V or a really narrow V. It doesn't matter if it's really wide, even wider, it's going to go left and right forever. Or it could be really narrow. It's still going to be going left and right forever. So the domain of any absolute value function, anyone that has this little absolute value functions that ends up being from a vertex making a V, it's going to be x equals all real numbers. Now the range are the y values, and clearly this thing is only at the y value of what? 0 and above, right? It's above. So you're going to say that it's at the y value of 0 and above. You're going to put y is greater than or equal to 0. And I think we concluded yesterday on the lesson that the k value ultimately told you what your range number is going to be. In this case, k is 0, so that's 0. And I think we also concluded yesterday that the a value tells you if it opens up or down, which technically tells you if it's going to be above or below a certain y value. So because the a value is positive, the range is y is greater than or equal to the k value, which is 0. Okay, so you could think of it just with the numbers, understanding that if it opens up or down, and understanding that the k value is either the highest or lowest y value, you could come up with the range that way, or you could think of it visually and you see that the lowest y value is 0 and above. So y is greater than or equal to 0. Moving on to number 4. This one's a little more fun. We always start with the vertex, which is a coordinate. That coordinate is, you think opposite on h, and you take k for what it is. So what is my vertex? Anybody? 3, 2. Thank you so much. Let's go to that most important point, 3 and up 2, and put a dot right there. And then from there, we need to rise and run according to our a value, which in this case is 1 over 1. So if you do go up 1 over 1, if you would have been negative, you'd be going down 1 over 1. But you're going up 1 over 1, put a dot there. And you could also go up 1 over 1 in the other direction. And you could continue to go up 1 over 1. And we might as well talk about this right now. In the future, when we get to parabolas, we're going to really lean on this vertical line called the axis of symmetry. I'm getting a little ahead of myself, but through any vertex exists like this line that we call the axis of symmetry. You don't have to draw it, but what it does, it gives you a reflection. It provides a reflection of this coordinate to the other side of that reflection line. So if it's 1 unit away, it's easy to put it over here 1 unit away. This one is 2 units away, so 2 units away would be right here. Again, this is something in the future that we're going to be dealing with, that green dotted line, which is called the axis of symmetry. I just wanted to mention it right now. Anyway, there's our graph. There's a vertex. It is opening up. It is going to the left and to the right forever. So the domain is x equals all real numbers. The range is y is greater than or equal to that 2 value. Okay. Visually, it's pretty simple. You see that the lowest value is at the y value at the altitude 2, and it is opening up. So y is greater than or equal to 2. Another way, even just looking at it on the equation, if the a is positive, it's going to be y is greater than or equal to that k value 2, that k value 2. Number 6. One half. Right here, the vertex is what? 0, 0. Thank you so much. So you put that dot at 0, 0. From that dot, how much do I rise and how much do I run? Yeah, according to A, which is up 1 over 2. So you're going to go up 1 over 2. And you could continue to go up 1 over 2. And you could use that pattern up 1 over 2, but in the other direction as well. And up 1 over 2. And what do we notice about this V? That it got wider compared to the original where the a value is 1, okay? I guess I didn't do 5, but let me just, so you could compare it. This one would be at 0, 0, and the a value is 1 over 1, so this is your regular, this is what we call a parent graph, okay? And if you compare the parent graph V to this new V is wider. So the reality is the a value here was 1, the a value here is 1, and the a value over here is 1/2. So as your a value gets closer to 0, it's going to get wider and wider and wider. If it actually got to zero, if you actually put a zero in front of the absolute value, zero times anything is zero. So it would say y equals zero, which would be a totally flat line crossing the y-axis at zero. So the closer the a value is to zero, the closer to a flat line you're going to have. The further away it is from zero, the narrower it's going to be. It's going to be the further away from a flat line. Okay. So jumping to number 8, this one is even closer to zero than 1/2, right? Half a tank of gas, you got a significant amount of gas. A fourth of a tank of gas, you got to start thinking of when you're going to gas up, right? So 1/4 is even closer to nothing, closer to zero. So it's going to be closer to a flat line. Once again, the vertex is 0, 0. And from that point, I go up 1 over 4. Check that out. Up 1 over 4, way over here. And up 1 over 4 in the other direction. And look at that. That's ugly. That is a huge, really wide V. Obviously, the closer it gets to zero, the closer it gets to a totally flat line. Do you get it? I hope so. In the future, we're going to call that a vertical compression, right? You could imagine like this original one, like if you put some heavy weights right here, it's going to compress it. It's going to make it wider. Okay, so the closer it is to zero, the flatter it gets, the wider it gets. We call that a future compression, vertical compression in the future. But down here, the a value is 3. So this is further away from zero. So this is going to cause it to become narrower. Okay, so the vertex again is 0, 0. Again, think opposite on h. There's nothing inside being subtracted from x. And there is no k value at the very end that's being added or subtracted. So technically 0, 0 is your vertex. From that point, you're going to rise 3, run 1. Why is that? Because 3 is the a value. Let me put that in blue the way I always do. So you're going to go up 3 over 1, and you're going to do the same in the other direction. And as you can see, that is definitely way narrower than the original parent graph. Original parent graph, a lot narrower. Why is that? Because right here, the a value is 1. It's a regular V. Over here, the a value is 3. It got narrower. The further away from zero, the narrower it gets. The closer to zero, the wider, the closer to a flat line it gets. Number 12. Is this going to be wide or narrow? It's going to be narrow as heck because I need to rise 7 and run 1 from the vertex. Let's start with the vertex. What is the vertex? 0, -2. Okay, so let's go to 0, -2, put a dot right there. And of course, we got that from the h value that is really nothing being subtracted from x, so h is 0. The k value, take it for what it is, it's a -2. So 0, -2 is a vertex. From that point, the a value is 7 over 1. So I need to go up 7, 1, 2, 3, 4, 5, 6, 7, what the heck, over 1. I'm right here. That is stinking narrow. And of course, you could map it over to the other side of the axis of symmetry and put it right there. Or you could count up 7 over 1 in the other direction. Totally fine. But check that V out. That's a super narrow, oh, that's ugly. Man, I wish I could draw straight. But you get the idea. It's a super narrow V. Questions? All right. How about 14? What's my vertex? 2, -3. Think opposite on h. Take k for what it is. So let's go to 2, -3. 2 on the x, -3 on the y. There it is. From that point, what am I doing? Up 5, 2 to the right, and to the left, technically, right? So we're going to go, let me see, where's this button at? Here we go. Up 5, 1, 2, 3, 4, 5, and 2 to the right, and also 2 to the left, okay? So I'm going to put a dot right there and over here. And there's my V. And you put arrows on it. Is this wider or narrower than the original parent graph? I know I haven't even moved it so you could see it, but think about it. Is this value greater than 1? What's 5 divided by 2? What's half of $5? $2.50, right? So 2.5 is greater than 1. Anything that's further away from 0 gets more narrow. Anything that's closer to 0 gets wider, right? So this is definitely more narrow than the parent graph. I mean, you could visually see that. Here's the parent graph, y equals absolute value of x. Compared to this one, it's slightly narrower than that one. And then for the last one here, I give you a graph and I want you to come up with the equation. And this is just a little taste of what we're going to be doing on the other side of this worksheet. So first, you need to know what the vertex form of an absolute value is, which is y equals, everybody should write this down, a absolute value x minus h plus k. And all you need to do is identify what the a is, what the h is, and what the k is, plug them in, and you'll have your function. You might have to simplify it, make it look a little nicer, but here we go. In order to identify the a value, I need to pretty much find the slope of one of these pieces. So from the vertex to this dot, what do? I'm going down 1 over 1, right? So that's a negative 1 over 1, which is the same thing as just negative 1, or you could even just put a negative sign, okay? But we'll do that in a bit. We still need to identify the h and the k. And where do we get the h and k values from? From the vertex. So what is that location? That location is negative 2 on the x, 1 on the y. Negative 2 on the x, 1 on the y. Those values are the h and k values. So the h is negative 2, the k is positive 1, okay? Now, to make this not confusing, I want you to rewrite this guy, but with blank spots right here, here, and there. I'm talking about writing it exactly the way it is, but instead of y equals a, put y equals blank spot, and then instead of x minus h, put x minus blank spot, and instead of plus k, put plus blank spot. And then you could simply plug in your a value of negative 1 right there. You can just put a negative if you want. You don't have to put the negative 1. And then the h value of negative 2 is going to go right there. And the k value of 1 is going to go right here. And that's your function. However, could we make it look a little bit nicer? Yeah, you could change that minus minus to plus plus. And you'll have y equals negative absolute value of x plus 2 plus 1, okay? So when is it that you think opposite on h? When you have the function and you want to graph it, what is your actual h value? It's the opposite of plus 2, which ends up being minus 2. But if you know your coordinate, you're not going to think opposite. Like if you know your coordinate, you know your h value. What is your h value? It's negative 2. And when you plug it in right here, with the minus sign, that's when the minus minus changes to plus plus, and that's how it looks. That's how it ends up looking opposite, okay? So go ahead and flip this paper over. Back here, we have a graph, and we need to come up with the function. And once again, just like we did previously, all we need are to identify 3 things: the a, the h value, and the k value. If you know those 3 things, you'll be able to write your function. And I always say, rewrite it with blank spots. Y equals blank spot, x minus blank spot, plus blank spot. The a value is the slope. So pick 2 points, that one right there, that one down there. What happens? You go down 1, 2, 3, 4, 5 over 1. So what is the slope? Negative 5 over 1. So the a value is negative 5 over 1. Put that right there. And then the vertex itself, what is that location? That's a location 2, negative 2, positive 1, 2, 3, 4, 5. So negative 2, positive 5. And that's your h, and that's your k. So you put in the h right in here. You put the k right there. And this is your answer. However, if you're taking a multiple choice test, you're probably not going to see it exactly like that. You're probably going to see it like this, written as nice as possible. Y equals negative 5, absolute value, x plus 2, and then plus 5. That's how you'd probably see it on a multiple choice. Because the minus minus changes to plus plus, so you just put a single plus. And that negative 5 over 1, they're probably just going to leave it as negative 5. You don't need to go over 1. So that's what we're doing on this back side. We are taking the graph, identifying a, h, and k, and then plugging it into this guy with blank spots. That way we don't make mistakes. All right, so we identify the vertex. The vertex is -1, 2, 3, -1, 2, 3, 4. So that is -3, comma, -4. That means that my h value is -3, my k value is -4. My a value is my slope, so count how much you rise from one point to another. You rise 1, 2, 3, 1, 2. So the slope is 3/2, which means that the a value is 3/2. Okay. So when we write this guy without the a, the h, and the k with blank spots, it'll be really easy to state our function. Y equals blank spot, absolute value x minus blank spot, close absolute value plus blank spot. The a value is 3/2. The h value is -3. And the k value is -4. The only other thing you could do to make it look nicer is change this to a plus. And you could also change that to a regular minus sign. So you have y equals 3/2 absolute value of x plus 3 minus 4. Moving on to number 6. Let's just jump right into it. Y equals x minus plus k. All right, so what is my a value? Anybody? I put these two blue dots, but I mean, if you went down 2, 1, 2, 1, 2, 3, 4, so you can say down 2/4, which will reduce down to -1/2 anyway, right? But yeah, down 1/2. So the a value is -1/2. And then the b value, or the h and k, I'm sorry, not the b value, the h and k comes from the vertex. And what is that location? -2 and 1, which means h is -2, k is 1. So you put the -2 right there and the 1 right there. Change the minus minus to plus plus, there's your answer. Of course, you don't need 2 pluses. Number 8. State your vertex. That is the location -2, 1, 2, 3, 4. So that's the location -2, comma 4. That's your h, that's your k. What is your slope? Pick 2 points. You go down 1/1. So the slope is -1/1. A is -1/1. So now you have all 3 bits of information, the a, the h, and the k. So when you think of this form right here, you could just plug it in. You have y equals, the a value is -1/1. You could just put a -1/1, or you could put a negative sign or a -1. Open absolute value, x minus h, and that h value is a -2. And then you have the plus 4 at the very end. And that minus minus changes to plus plus. And there's your answer. Moving on to number 10. State the vertex here. That's the location 2, 1. So if you write that down, 2, comma 1, you now know your h and your k. And if you think about the slope from one point to another, you're going up 2/1. So the a value is up 2/1, which is just 2. So now we could focus in on plugging in the a, the h, and the k. I always rewrite it with blank spots. And then I actually plug in the a value in front of the absolute value, plug in my h value of 2 and my k value of 1, and there's nothing to do. There's no minus minus that I need to change to plus plus. There's no plus minus that I need to change to minus. That's it. That's as simple as it gets. Fun stuff. What's a vertex? Vertex is -1 and 3. That means that the h is -1, the k is 3. What's the a value from one point to another? Yep, 1/4. So the a value is 1/4. So let's write this out. Again, I'm just going to write this over, but without the a, the h, and the k. I want to leave blank spots. And we plug in the a value right here, 1/4. Plug in the h value of -1 right in there, and the k value of +3 right there. What else could we do to make it look nicer? Change the minus minus to plus plus. So if you're doing a multiple choice test, you're going to see a single plus sign right there. And number 14, What's a vertex right there? That's -3, -4, correct? 1, 2, 3, 1, 2, 3, 4. Oh no, 5. My bad. So we now know our h and k. Our a value is simply 2 points from one to the other. What's happening? You're going up 1, 2, 3 over 2. So the a value is up 3 over 2. So now we could actually write our equation. Y equals, the a value is 3 over 2. Open up absolute value, x minus the h value, which happens to be a -3. Close the absolute value, and then put the minus or the plus -5 for your k value. And of course, you could simplify it, putting a plus plus and changing the plus minus to a minus. So your final answer would be y equals 3/2 absolute value of x plus 3, close absolute value minus 5. Last one, 16. And I've done all the even questions for you. The vertex is 0, 2. That's right. 0 on the x, 2 on the y, which means your h value is 0, your k value is 2. And how much do you rise and run from one point to another? You rise 1, 2, and run 1, right? So the a value is 2 over 1. So using this guy up here, you're going to go y equals a, absolute value of x minus h, plus k. Notice that I left blank spots, so y equals a, which is 2, or you could put 2 over 1, and then x minus h, which happens to be 0, and the k value is 2. So how could we make this look nicer? You don't really need the minus 0. X minus 0 is still x, right? Even x plus 0 is still x. So the simplified function that you would see on a multiple choice test would be y equals 2 absolute value of x, close absolute value plus 2. And of course, you should always be able to state the range of any absolute value function. You could visually see that it exists at the y value of 2 and above. So the range is y is greater than or equal to 2. But you technically don't even need to see the graph. You could just look at this guy and be like, okay, if I want to state the range, it's y is, because the a value is positive, it's going to be opening up. So the range is going to be y is greater than or equal to, because it's opening up. How do I know that? Because the a value is positive. And what value is over here? It's going to be the y value of your vertex, which happens to be the k value. So y is greater than or equal to 2. So you don't really even need the graph to state the range. Anyway, let's finish this up. And once you're done with this, you should be able to ace the assignment that we have on quizzes in Google Classroom.